Hi there, folks. Today we're looking at series and sigma notation. And series is really just a sequence, but it's a sequence in which we add all the terms together. Okay, and so it's that slight difference. A sequence follows a pattern. We list the numbers. We put commas in between those numbers to just show them in a list. But a series is basically we take those commas and replace them with plus signs. So we actually do a mathematical operation with the terms of that sequence. So a series is the sum of the terms of a sequence. And since a sequence can kind of keep going forever if we keep the pattern going, when we look at a series, we typically look at a chunk of that sequence. All right, so in other words, we might only look at the first 7 terms of that sequence. And so we'll look at those first 7 terms as a series, and we'll add together, we'll find the sum of those first 7 terms. Or maybe we'll look at terms like 7 through 20 of that pattern. All right, and we'll take terms 7 through 20 and we'll add them together. All right, and so when we look at a series, we're typically looking at chunks of a series, pieces of the series at a time, so that we can add those terms together. All right. Sigma notation, also known sometimes as summation notation, is really just a way to display a series, but using mathematical equations to display that series. For example, when I look at this, so that capital E looking thing, it looks like a big capital E, but it's a little bit strange and pointy. That is the capital letter sigma. All right. And in mathematics, when we see uppercase sigma like that, it indicates a sum. All right, so when we're talking about the sum of something, we'll use sigma to denote that. And so here's how we kind of read this thing. So sigma means the sum. The equation that's in there, that's the equation that's going to yield the terms that we need. All right, so that's going to yield the terms of the series for this thing. Okay, so this gives us the terms. In other words, this kind of gives us our a sub n values. That'll translate into a sub 1 and a sub 2. And a sub 3, and all the terms that we need to add together, okay? The other piece of sigma notation, so the equation gives us the terms that we're going to add together, but the question is, which terms do we want? How many terms are we going to have? And that's what these little numbers over here indicate. So this guy right here, this is like where we start with sigma notation. In other words, we want to start with a sub 1 because it says we want to start with an n value of 1. We want to start with the first term. And we don't always start with the first term. We might start with the 5th term. Like I said before, we might look at terms 7 through 20. And so this is the term that we start with. So that's the starting term. And then up here, this is the term that we end with. Okay, so this is the ending term. All right? And so when you look at this particular example, if we kind of translate this, if I want to start with the first term of this thing, in other words, I'm going to plug that 1 in for n. And when I plug the 1 in for n, okay, I get 2 times 1 is a 2 plus 3 is a 5, so the first term is a 5. And I don't want to stop with that first term. Next, I want to plug a 2 in for n, okay? And I'm going to keep going until I get all the way to the 5th term. So I'm going to plug a 2 in for n this time. And when I do that, 2 times 2 is a 4, plus 3 is a 7. And now I'm going to plug a 3 in. That's a 6 plus 3, which is a 9. And now I'm going to plug a 4 in. That's an 8 plus 3, which is 11. And then last, I'm going to plug a 5 in. And I know this is the last term because, again, that's my ending value. So I plug a 5 in. And when I plug a 5 in there, I get a 13. And what I'm going to do now is I'm going to add all these terms together. Okay? And so as I add these guys together, it looks like I get a 45 for this thing. Okay? And so the sum that this thing was trying to display is 45. That's my net result, but I get to that by looking at a certain number of terms of this series. Okay, a couple things that you should take note of here is, after we punch in that first term or two, we should recognize the pattern here. The pattern here is that these values are going up by 2 each time. So I started with a 5 and they're going up by 2 each time. And once again, I have 5 terms. This is the first term, the second term, the third term, the fourth term, and the 5th term. So just by recognizing the pattern, I could easily get the rest of these values without actually plugging each of them in. Okay, I should have no need to plug the 4 or the 5 in. I should recognize the pattern by that point. And really, if you understand equations and the relationship between equations and sequences, you should recognize right away by this equation that the terms that come out of this equation are going to give me an arithmetic sequence. And when you think about an arithmetic sequence, well, that's when we're adding the same thing each time. And if you understand the relationship between that and a linear function, you should realize that the 2 right here, that's the thing we're adding each time. And so the function recognition here and recognizing the format of the equation and how that relates to a sequence, well, that can save you a lot of time and work and energy here, okay? And so when we look at this in slope-intercept form, that's like the 0th term, which is here. So then the first term would be a 5, and then the next one a 7, 9, 11, 13. Without plugging anything in, just using the pieces of the equation, you should be able to write these terms, okay? So look for those kind of things. Look for some of those shortcuts that are involved here, okay? If I look at something like this guy, same kind of thing. I want to go from terms 1 through 7. If you recognize the format of this equation, you should go, well, let's see, that's like the 0th term, so that'd be a -2. And then the first term, well, this is the thing I'm adding each time. That's like the slope. That's what I'm going up by each time. So the first term, this is the 0th term. So the first term, well, that's going to be 4 higher. So that's going to be a +2. And then the second term, if I kind of keep the pattern going, well, that's going to be a 6. And so when I translate that into what I want down here, I wanted to start right here. I wanted to start with the first term, n of 1. Well, that's the 2. And so just be careful in terms of which term you want to start with. In terms of the starting value, it's easy enough just to plug that one in and say, okay, I get a 2. But then use the equation. Recognize that, hey, I'm going up by 4 each time. So let's see, the next term is going to be, sorry, I switched colors on us. It's going to be a 6. Okay, the next one's going to be a 10. The next one is going to be a 14. And then an 18. And then a 22. And I could keep doing this all day, but be careful. Make sure you don't go too far. This is 1, 2, 3, 4, 5, 6. I need one more. 7. Okay? Make sure you stop at the stopping value that's listed here, the stopping value of 7. So I was trying to erase that guy. Okay? And now from here, this is really just a job for my calculator. I go ahead and plug this thing in, or we could do it by hand, I guess. Be smart about it, like the 26 plus the 14 is a 40. These guys together is another 40. That's 80, 98. Okay? So we got a total of 98 for this one. All right? But again, that recognition of the pattern, that recognition of the equation makes it a lot easier and a lot faster to do this thing. I could literally plug a 1 in here, and it'll give me this first term. And then I could plug a 2 in and get the next term, and then plug a 3 in, and a 4, and a 5, and a 6, okay, and a 7, until I have all the terms. So I could just plug different n values in order to get all these terms. But again, save yourself a little time by recognizing the equation, recognizing the pattern. If I look at something like this guy, as soon as you look at it, hopefully you recognize the format of that function that's in there. The format that's in there is an exponential function, which means this thing's going to be a geometric pattern. Okay? And so when we look at the values without the plus sign, without the addition, if we look at them from the perspective of a sequence, we should see a geometric sequence being formed here. Okay? And again, if you're unsure, just plug a 0 in. In other words, right here, it says we're starting with n of 0 this time, so I plug a 0 in for n. And if I plug a 0 in for n, 2 to the 0 power is 1, times 3 is a 3. So my the first value I'm going to use in this series is a 3. Okay? And then I could just continue here and say, oh, let me plug a 1 in next. Or if you recognize this thing and say, hey, wait, the r value is 2. I'm going to multiply by 2 each time. So the next value is a 6. The next one is a 12. The next one is a 24. The next one is a 48. And you keep going until you have them all. Let's see, that was 0, 1, 2, 3, and 4 is where I stop. Okay? And so here I'm going from the 0th term to the 4th term, which is really 5 values, which is why I have 5 values here. Okay? Again, if you're not sure, well, you just keep plugging terms in. So I plugged a 0 in and I got the 3. If I plug a 1 in, 2 to the first power is 2 times 3 is a 6. It gives me the next term. Okay? If I plug a, what am I up to, a 2 in, 2 to the second power is 4 times 3 is the 12th. Okay? And I could keep doing that until I plug in all the way up to a 4. All right? And now once again, I'm going to add these guys together. And when I add these up, again, choose an order that makes the most sense. Like these guys added together is a really nice one that gives me a 60. These guys added together gives me a 30. So now I'm up to 90, and then plus the 3 is a 93. Okay? So if you're doing this by hand, add them in an order that's easy. Okay? If I look at something like this guy, once again, this is where the pattern recognition really, really pays off. Okay? In the previous couple, I only had a couple terms to find. It's really not that hard to plug each value in. But as we get more and more terms, we look for more and more shortcuts. Okay? And so for this one, notice here, be really careful. I'm starting with the second value. And so for this, just plug it in. Just plug the 2 in is probably the easiest way to identify the second value. Yeah, I could start with 25 as the 0th value and then go up or go down by 2 each time or up by -2 each time, add -2 each time to get to the second term. But again, if you just plug it in, 2 times a -2 is a -4, plus the 25 is a 21. So that's where I'm starting. I'm starting with that guy. But then if you recognize this function and say, hey, that's the thing I'm adding each time, well, now I know that the next value is 19. I know that the next value is 17. Okay? 15, 13, 11, 9, 7, 5, 3, 1. And I keep going until I get to 15. Let's see, this was a 2. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm not quite there yet. I got to go a couple more. The 13th term. The 14th term. I'm running out of space. And the 15th term. Okay? And now I can add them all up. But again, it saves me a ton of work. Yeah, this is a little bit tedious and a little bit annoying in terms of all the values I have here, but it saves me a lot of work to use that little bit of pattern recognition to understand, hey, this function represents an arithmetic type of sequence in terms of the values themselves. It's linear. I'm adding the same thing each time. The thing I'm adding is that -2. Okay? You could literally plug the 2 in for n and get the 21, and then plug a 3 in and get a 19, and then plug a 4 in and a 5 and a 6 all the way up to 15 to get all of these same values. But it saves us a lot of time when we use some of that pattern recognition. And so now I just add all these up. And this one might be just easier to plug into the calculator. So if you kind of just plug away here, gives you a 112 when you add them all up. Okay? Yeah, you could still do this one by hand. It wouldn't be that hard. But you might lose track of some things, especially if you're kind of doing it out of order. All right? If I look at the next one, same kind of thing. I want to start with a value of 3 this time. Notice I'm looking at the 3rd term through the 10th term this time. All right. And so when I look at that, I'll end up with 8 terms when I look at the 3rd, 4th, 5th, 6th, 7th, 8th, 9th, and 10th terms. And so again, just start by plugging that 3 in. If you plug the 3 in, 1/2 to the 3rd power is a 1/8, and then times the 512 is going to give me a 64. Okay, so that's a 64 for the first value that I'm going to use. It's the 3rd term. But now I just keep the pattern going. And if I recognize this thing, once again, I could plug a 4 in and find the value, and then plug a 5 in, and then a 6, and then a 7, then an 8, and then a 9, then a 10. So I could plug each of those values in to get each of these. Or I can look at it and recognize, hey, that's the R value, that's the B value, that's the thing I'm multiplying by each time when I look at a geometric sequence or when I look at exponential growth or decay. Okay? And so that's the thing I'm multiplying by, which means the next value is a 32. The value after that is a 16. Next is an 8, a 4, a 2, a 1. And again, I just have to kind of keep track of this was the 3rd term. 4, 5, 6, 7, 8, 9. I need one more. It's the 1/2. Okay? And so I'm just working my way through the number of terms that it has requested that I use here. Now I add them up. So again, if I plug most of this into my calculator or all of it into my calculator, what I end up with is 127 1/2. Okay? Or if you wanted to write that as like an improper fraction, depending on what the question asking for, it would be 255 over 2. Okay? And so depending on how the calculator spits it out, of course, the calculator would probably spit it out like this. Okay? But any one of those would give us the appropriate sum here. All right. The reason I show it as a fraction is because sometimes as these things get more and more decimals involved, and this one didn't have a lot, but we'll get some ridiculous decimals, and we don't want to necessarily round that off. We're probably going to want a fraction instead so we can have an exact value in terms of the sum. Okay?